This is the June 2017 Regents exam. Right, so number one, they're giving us the congruent statement and they're asking for the sequence of transformations. Okay, good. The first thing I typically check with this is to decide if there's a line reflection going on. And it looks like there is. The reason that we can be certain is from A, as we travel to B, then to C, you're looking at a clockwise arrangement of the letters. We call that orientation. And then when we go D, which is corresponding to A, over to E to F, what we did was we switched that to a counterclockwise orientation. So it's an odd number of line reflections must have been used. So there's at least one line reflection, and it has to be an odd number in total. A rotation and a translation won't switch the orientation. Rotation, translation, nope. So those two are out. A reflection over the y-axis looks good. That would place A prime here, B prime approximately there, C prime over there, and then it'd be great to use a translation. So yeah, I'm thinking y-axis and translation. All right, choice two. Number two, area. Okay, so it doesn't say that this triangle is a right triangle, but we can find out if it is or not. So 3, 1, 2, 3, 4. So what I'm doing right now is this looks like it might be a right triangle. And it is. The slope of PQ is, if you do this rise over run, negative 6/8, which is negative 3/4. And QR, that slope is positive 4/3. These slopes are negative reciprocals, so it is in fact a right triangle. We could use areas 1/2 base times height after we calculate the lengths of those sides. This one's going to be 5, this one's going to be 10, okay? Using Pythagorean theorem. So my area is going to be 1/2 times 5 times 10. So that's going to get us 25. If it were not a right triangle, what we've taught students is potentially a box method. Even if it is a right triangle, we can use this box method. What we do is we box in the figure, and then what we do is we tend to cut away all the extra triangles. We cut those off. We subtract away the area of each of these. That's what I'm going to demonstrate just to cover that standard in case we were to need that. Okay, so I'll continue counting. I'm just counting these lengths. Okay, so basically I'm going to call this one triangle 1, this one triangle 2, and this one triangle 3. So the area of the box first, it's a rectangle, so it's length times width. Looks like 10 times 8, which is 80. The area of that first triangle, the one over here, is 1/2 of 5 times 10, 25. Area of that second triangle up top, up there is 1/2 times 8 times 6, 24. And that third one is 1/2 times 3 times 4, which gives me 6. Now I'll add up these triangles, and that's 55. So that's the extra. 80 take away 55 is 25. So that was verified. It is 25. So a couple ways to do that problem, just in case we might need it. Number 3. Okay, this is the cofunctions. Cofunction values are equal when angles are complementary or add to 90 degrees. Okay, how do they tell us this? they tell us that angle C is a right angle, 90 degrees. So indirectly, they're saying A and B are complementary, not congruent, but complementary. So for instance, perhaps one of them, actually I can figure out, just give me a second. So looking into it a little bit, so cosine B equal to 5/13. That means adjacent over hypotenuse, 5 over 13. That's kind of how it would play out. Now, we don't need any of this for this problem. There's supposed to be a really big shortcut, but just want to show you basically that these add up to 90. So after doing the calculation, this is around 67 degrees. This is around 23 degrees. Okay. So what you're seeing is that these two angles do add to 90, since obviously that one's 90. So the cosine of 67 is 5 over 13. The sine of 23 should be the same, the ratio of the same two sides. So they should be the same. The shortcut to this problem really was supposed to be when the cofunction values are the same, I'm sorry, when the angles add to 90, their cofunction values should be the same. So since A plus B is 90, cos B should equal sine of A. So that's the other one. That should equal 5/13. There's a few ways to do that problem, but the shortest is you're supposed to just know that theorem. Okay? All right, so for this one, a lot of my students went the wrong way here. When they do go A to B to C, they're essentially saying follow this path, start at A, move past B over to here, and stop there, and then that is 268 degrees. Now, all the way around is 360, so we're going to subtract 268, and that'll get us 92. So from here to here is 92 degrees. The relationship between an inscribed angle, right, vertex is on the circle, opens up to this arc. The relationship is the measure of the angle should be half the measure of the arc angle. Okay, so the measure of angle B should be 46 degrees. All right. Next, let's see. Okay, looks like we have a proportional situation here. Trapezoid, got it. Okay, the key is trapezoid gives us those parallel. Okay, so that these, let's see, those will be the same. Sorry about that. These will be the same. All right, so basically with these being parallel, what we have is the side splitter theorem is in place. Okay, so when you have a parallel side through a triangle, it should split the sides that it goes through proportionally. So what we're saying is 2 should be proportional to 4 as whatever this is to this. Okay? Now I think the best way to do it on a part 1 is to use your choices to your advantage. Okay? Now we want TR, right? Altogether, MR is 9. We could test the examples. We could test some of the sides. It's not going to work for anything except 6 here. Now here's a way to do it. If I put 6 there, it forces 3 to be there, right? 9 minus 6 is 3. Now, here's how it should work. The side splitter theorem should make all these proportional. So 2 is to 3, right? As 4 is to 6, if the side splitter theorem, or if this is the right answer for this. Now, when we cross multiply, it's a question basically, is 3 times 4 equal to 2 times 6? It is. Since that works, this is the answer that would produce proportional sides, and we'd have it. Now, some students try to tackle it algebraically, which is good, so I'll show that. Same concept. Since the whole thing is 9, and we don't know what this is, we could call it x, and then we could call this 9 minus x. Okay, 2 and 4. There's another way without using side splitter theorem as well. I know some of my students tried, but let's go this way. So 2 is to 9 minus x as 4 is to x. And then we can cross multiply. Distribute on the other side here. Add 4x. And we will get x is 6. That's the way to do it with the algebra. Okay? You could have put these together and made that 6, so there's another option as well. Okay, moving on. Last one for this video. So a line segment is dilated. Okay, common problem. By a scale factor of 2, centered at a point not on the line segment. Okay, that's important information. There's really two types of problems for this. If we dilate a line and the center is off the line, segment, line, whatever you want to call it, what would end up happening is we would produce a parallel line that's not the same line. Okay, basically what I'm saying is the point there, A, would move along this path, and that would become A prime. Point B would move along this path, and this would land on B prime. So basically the image is going to be parallel to the pre-image, but a different line. Now, the other possibility is if you have a point where the center of dilation is on the line. Now, what will happen is, let's just call that C for center. What will happen is A and C have to continue to be collinear, or the image of A, I should say, A prime. So what will happen is A, if we dilate by a scale factor of 2, sorry about that, it'll go a little further away. Okay, so this distance here will double, so A prime would land right about there. Now, it's still on the same line, even though it's further from the center. Okay, so also just to show you, maybe B is, much further away than A was. But again, that distance doubles, so B prime lands there. So the individual points may move, but you end up still being on the same line if you have the center that's on the line. So, which one is it? It's this one. Let's look for the choice. The line segments are perpendicular. Wrong P word. It's perpendicular. No. The line segments are parallel, and the image is twice the length. Yes, that's got to happen. So let's say this is 10. The image would be 20. So that does have to happen. Okay, scale factor of 2 makes it an enlargement. This would make it a reduction. No good. All right, that's it for the first video. We'll do more on the next one.